Alright, so, true story here. One time I was at a place called Chickies Rock climbing, and while I was there were some people up here that I hadn't seen or heard. And one of them decided to kick his flip-flop off, and the flip-flop came flying down and landed somewhere down here, where I was sitting. Okay, so today in class we're going to figure out where exactly the flip-flop landed. Okay, so here's our problem. It says, a person standing at the edge of Riverview Ledge at Chickies Rock. So, this is called Riverview Ledge. So, he was standing at the edge at some point. Apparently, I wasn't looking up, so I didn't see him. Connolly kicks his flip-flops over the edge with a speed of 1.2 meters per second. Okay, so what that means is he kicked his flip-flops this way. When he kicked them, he only kicked them in the horizontal direction. He didn't kick them up at all, he didn't kick them down at all, just off to the side. And then eventually, as soon as they're off his foot, gravity does start taking over and they pulls it down as well. Some other things we know. The cliff is 30 meters high. So this is 30 meters. How long does it take for the flip-flops to fall to the ground? How far do the flip-flops travel horizontally? And considering that I was sitting 3 meters from the edge of the cliff, how do you think I felt? So, let's go ahead and take this one part at a time. So, how long did it take the flip-flops to hit the ground? Well, the first thing I'm going to do is write down my givens. So we knew that this was 30 meters. We knew that the velocity up here was only in the x direction, and it was 1.2 meters per second. I'm going to write down my givens, and when I do that, I'm going to write them down in two columns, an x column and a y column for the x and the y directions. So an x column and a y column. Okay, so in the x column, what do I know? Well, the x column, there's not going to be any acceleration over here, okay, because gravity does not pull us to the right, does not pull us to the left, it only pulls us in the y direction. So over here, the only variables that I'll have are a velocity in the x direction, a displacement in the x direction, and a time. Okay? Over here in the y direction, my possible variables that I could have would be an initial velocity in the y direction, a final velocity in the y direction, an acceleration in the y direction, a time in the y direction, and a displacement in the y direction. So these are all the variables that I could have in the y direction. So I want to start filling these in. Well, first number I come to is a speed of 1.2 meters per second. And it said horizontally. Well, that means he kicked them only in the horizontal direction, which means that this is the horizontal speed. The cliff is 30 meters high. Well, that's up and down. That's a y direction. So I'm going to put that over here with the y. 30 meters high. How long does it take for the flip-flops to fall to the ground? So I'm trying to find the time. And it doesn't matter which time I find, because time is what links these two. It's going to hit the ground after 5 seconds. Okay? Whether or not I'm talking about the y direction or the x direction, it took 5 seconds to hit the ground, okay? So time is the link between the two different directions. How far do the flip-flops travel horizontally? So we want to know this eventually, so we don't know it yet. And considering I was sitting 3 meters from the edge of the cliff, how do we think I felt? All right, so we don't have any of the other information, all right, written down. But we do know some things. Go back over to the y direction. These flip-flops, they are in free fall, and when an object is in free fall on Earth or close to Earth's surface, we know that the acceleration due to gravity is negative 9.81 meters per second squared. Well, what else do we know? We need to know something else, one of these two. Okay, I don't know how fast they hit the ground, but I do know that they were only kicked in the horizontal direction. So when they first started moving over here, as soon as they left, they were only going this way, and then gravity pulled them down. So there was no velocity in the y direction to start. That's 0 meters per second here. Now I'm going to go look at my equation sheet and look for an equation that has initial velocity, acceleration, time, and the vertical displacement. And I find this equation. Delta y equals the initial velocity times the change in time plus 1/2 the acceleration times the change in time squared. So I want to fill some things in, but before I get too carried away, got one thing written up here. It's not exact. This 30 meters. These flip-flops, they didn't go up 30 meters. They fell 30 meters. They went down 30 meters. So I really should make this a negative 30 meters. So I'm going to substitute in negative 30 is equal to 0 times the change in time plus 1/2 times the acceleration due to gravity, negative 9.81 meters per second squared, times the change in time squared. 0 times the change in time is 0. Kind of cancels itself out. So now I've got negative 30 equals negative 4.905. I just multiplied 1/2 times negative 9.81 times delta t squared. Divide both sides by negative 4.905. And we will find that the change in time was 2.47 seconds. Now, like I said before, this is 2.47 seconds to hit the ground. It doesn't matter that we were worried about just the y for now. It's also that exact same amount of time in the x direction. So we're going to use that for part 2. All right, so let's go back and get some information. So we know Vx, delta x, and delta t. So in the x direction, the velocity was 1.2 meters per second to start. The displacement's what we're trying to find. Delta t is what we just found in the last part, so it's 2.47 seconds. And I could write down all my y information, but it asks how far do the flip-flops travel horizontally. So I'm trying to find delta x. So I don't really need the delta y information right now. So go to our equation sheet. Velocity, average velocity, is equal to the change in displacement divided by the change in time. Substitute in 1.2 meters per second is equal to the change in displacement over 2.47 seconds. Multiply both sides by 2.47. The change in displacement is equal to 2.97 meters. Considering I was sitting 3 meters from the edge of the cliff, how do you think I felt? Well, the flip-flops landed 2.97 meters, and I was sitting 3 meters, so the flip-flops landed 0.03 meters away. If we convert that to centimeters, that's 3 centimeters. So the flip-flops landed 3 centimeters from me. So how do you think I felt? If you're going with scared, you would be correct.